Hello and welcome everyone to the LabVIEW exercises. Today we will do another exercise on serial communication between Arduino and LabVIEW. So the purpose here is to acquire some sensors data with Arduino and then display it on LabVIEW via serial communication. So for this purpose, let's just start from the very basic sensor, which is ultrasonic sensor here, and its connection diagram with Arduino will look like this. So after making its connection diagram, we will move on to its Arduino code. Since in serial communication with Arduino, we must need an Arduino code which will run to use basically to control motor or acquire any sensors data. But all we will do is in LabVIEW is to acquire that sensors data which is fetching from the Arduino basically. So let's just start from here. So now we will just jump on to our LabVIEW programming environment to see how we can acquire this sensors data that we have seen in the Arduino serial monitor into LabVIEW. So for that purpose, let's just go to our block diagram here, and then I will go to instrument, and here I have instrument drivers, Visa, GPIB and serial communication. I will just pin it down in here, and let's just go to Visa or serial monitor, and here I can get the configuration port sub VI, and then what I will do is I will use write function and then read function and then close function from here, and I can also use this bytes at port, which is I'm just making a very simple right now serial communication VI between this LabVIEW and Arduino. So what I will do here is I will use a while loop in here to enclose these functions right now. So I will just connect, I will just first of all I will give the control as the resource name at which COM my Arduino is connected, and then all of these things will be the same, but we can give another so the 10 seconds here is the time of timeout. If there is no connection between this time, this VI will time out, then we have to run this VI again. So what I will do is we can increase this time by adding 0 at the right end, so it means now it is 1 minute or I can say 100 seconds it will take to stop or reset or the timeout. So now I will just simply connect it with my write function, and then I will just connect it with the bytes at port, which means that it will read all the bytes. After sending this command, it will check how many bytes or what is the data is receiving at the port. So I will connect this at the read end, and then I will just connect it out with my close function. We can also simple error handler in here, but right now I will just give it left it, and now I can just increase its space. For the better data acquisition purposes, I will use a little bit of delay, like say 500 milliseconds, and then I will use a control function to control the while loop. So here is the stop button, and then similarly I have to read the data, so I will create an indicator in here. So read the buffer. So now what I will do is, now the main point to note in here is how we will acquire the sensors data from Arduino. So as we have seen that since the serial monitor is reading this value distance, so it is the value is serial.print distance. So now what we will do is we will just upload the code again in here. As we can see, the code is just uploaded, and with now without going to serial monitor in Arduino, we will just use our LabVIEW program. Now I will again refresh and then select the port and run my program. Here it is just showing me 29 centimeter. Now if I just bring in front of it something like my breadboard, now it is reducing the distance. Similarly, if I just increase with the distance, it is consistently increasing or decreasing the distance. So right now anything which is just requiring the data in Arduino, it is just simply shown in LabVIEW. So it means that we can use any kind of Arduino code and acquire the data and then read it in LabVIEW and then manipulate the data by using some various functions which can be very useful in LabVIEW. So now here this time we have just changed our sensor to do another exercise so that we can see if we can acquire other sensors data. So here we have MQ135 gas sensors, which is to detect usually carbon dioxide or other poisonous gases. So here what I'm going to do is I will just upload this code in Arduino, and this code is very simple ones. It will just see the analog values from the MQ135. So right now if I just open up my serial monitor, I can see the values at 92, 93. So if I use this room spray, which has many poisonous gases, as we can see the ingredients. So if I will just make a little bit of spray directly in front of this, so we can just see the values are increasing. So it has gone from 135 to 150 from, and now it is decreasing its value from as we can see right now it is consistently decreasing since it is just checking the values from the regular intervals of 150 milliseconds. 150 yes, 150 milliseconds. So that's how it is working. So now if I just close this serial monitor and then go back to my previous LabVIEW program, and then again if I just refresh it and then again use the COM port and then run my program, here it is showing me the air quality right now, which is 109 ppm. So if again I will just spray a little bit, now it has just gone to 400 and then just decreasing because I have directly exposed the spray on the sensor. So that's why the values jump too much, because it contains the liquid as well. So I just unwillingly exposed the sensor with the liquid, so that's why the values gone very high. Now they are decreasing. Now this time we are using two LEDs to represent two relays, or we can say buzzer or anything to control the digital basically. So the purpose here is to control the LEDs which will be connected at the pin 2 and 4, and then the pin mode LED is output, and this is the Arduino code to use. So here the key is if the variable is serial.read, and if the variable is A, which will be sent it from the LabVIEW, then the pin mode will be high. If the variable is W, then it will be low, and similarly for LED second, if the variable is B, then the pin mode is high. So here is the code that we are using for this purpose. So right now if I just go back to my front panel and run the program in here, and then if I just turn on the relay 1, then as we can see green LED is turned on, and if I just turn on the relay 2, then the red one is turned on. And similarly we can turn off or on. These are representing as relays. So that's how we can also control digital inputs in LabVIEW. So our last exercise in here is to control servo motor using LabVIEW and Arduino. So for this purpose, I am using this Arduino code to control the servo motor via serial communication or the serial signals. So here we have included the servo.h, then servo as an object. I have used obj, and the yellow pin, which is our signal pin, is at 8, and then here is the serial.begin 9600, while serial.available, which is equals to 0, which means that if the serial has a value of 0, compares the value, which double equals to means compares the value, and int value is equal to serial dot parse int, and then we have object dot write value, and I have given the delay of 5000. So right now here is my LabVIEW code which I am using, which is quite a simple code. Here I have used this visa resource name, and as we have used the serial dot write visa write function, and this is the decimal places at which it will be shown. So right now, if I will just here I am missing out something. So as I am using serial, then I should also close it and connect it with these strings. All right, so now